All right, last data 5.3. So in this one, again, we're talking about finding the area of a regular polygon, and we know that the formula is the A equals 1/2 times side times apothem times number of sides. So remember that S is side length, A is the apothem, N is the number of sides. The apothem is a perpendicular segment from the center to a side. So if we look at this figure, the apothem goes from the center and it has to be perpendicular to a side. So this little piece right here is our apothem. The apothem is unknown, so we have to figure out what that length is, otherwise we won't be able to find the area of this figure. So we're going to need to use this triangle to help us figure it out. And in order to do that, we need to figure out another piece of this triangle. But first we want to start filling in the pieces that we already know here. So we know that S is equal to the perimeter divided by the number of sides, so 104 divided by 8 in this case, which 104 divided by 8 is equal to 13. So the whole side length is 13. The apothem we do not know, so we're going to leave that part blank for now. And N is equal to 8. There are 8 sides in this figure. So if we know that the whole side length is 13, we only need this portion to find what the apothem is, to help us find the apothem. So we're going to take that 13 and we're going to cut it in half. So we know that this length is 6.5 right here. So now we've got this smaller triangle where we've got 6.5 here, our apothem here, and 8.5 off to the side. So remember, if we turn this corner into an arrow, it points at our hypotenuse, which is always going to be C, because we're going to need to use the Pythagorean theorem. So if we do A squared plus 6.5 squared is equal to 8.5 squared. So A squared plus 42.25 is equal to 72.25. If we subtract 42.25 from each side, we get A squared is equal to 30, and if we take the square root of 30, we get 5.47, and 5.47 rounds to 5.5. So now we have the missing piece of our puzzle. We can plug the 5.5 in here, multiply everything together, 0.5 times 13 times 5.5 times 8, and that gives us 286. Again, just to point out, these two numbers don't get used in the area formula. Their only purpose is to help us figure out what the apothem is, and once we're done with that, those two numbers are done. They go away. All right, in the launch today, we talked about how figures get inscribed into circles. And as the shape increases sides, number of sides, so this is 4, as our number of sides increase, our figure starts to look closer and closer to a circle, and our apothem gets closer and closer to the radius. Okay? So today what we're going to do is, again, we're going to calculate the area of regular polygons. Instead of calling them regular polygons today, we are going to find the area of circles, but we're going to use it, we're going to find it using a modified version of this regular polygon formula. So, we know that area is equal to 1/2 times S times A times N. We also know that if we take side times the number of sides and multiply those two pieces together, side times the number of side gives us the perimeter. So A is equal to 1/2 perimeter times the apothem. If we think about what happened in this launch, we know that the apothem got closer and closer to the radius of a circle. So we can take this A out and we can replace it with R for radius. We're going to leave the 1/2, that's going to stay there. And we know that the perimeter of a circle, perimeter is just the distance all the way around the outside edge of the circle, and we know that that is also called the circumference. So that is how they're getting this formula right here. A is equal to 1/2 the circumference times the radius. But most of us also learn that there's another formula for the area of a circle, and I just am going to show it to you guys today so that we can kind of compare and contrast answers when we use this formula versus this formula here. So the one that we have probably learned more frequently is this A equals pi r squared. And we also know a formula for circumference, and I don't like how they write that, so I'm just going to write this like this. So circumference is either 2 pi times the radius or pi times the diameter. And again, these two are the same thing. Sorry, these two mean the same thing because the radius is halfway across, whereas the diameter is all the way across. So if you take the radius times 2, it will give you the length of the diameter. All right, so we just have a few examples today. So a frisbee has area of 154 inches and a diameter of 14 inches. We want to find its circumference. So we know that the circumference is either going to be pi times the diameter, or we know that it's going to be 2 pi r. Well, in this case, they've given us what the diameter is, so we want to use the formula that uses diameter. So we're going to ignore this formula for now and just use this formula here. So we can do C is equal to 14 times pi, and we can leave our answer like this. We would just put an inches squared after, and if pi isn't our answer, then that means that that is an exact answer. If we want to give an approximate answer, we can take the pi out. Sorry, this would not be squared. This would just be inches because we're talking about circumference, and circumference is a length, not an area. We can take that pi out and replace it with the approximation for pi, which is 3.14. So if we take 3.14 times 14, we get 43.96. And this would be inches. So this would be an approximate. Circumference. Okay. Number 2, a circular garden has a radius of 1 meter, and the circumference is about 6.25 meters. What is the area of the garden? So we've learned 2 formulas for the area of a circle. So one of those formulas is area is equal to pi times radius squared, and the other is A is equal to 1/2 circumference times the radius. We have enough information to do both of these, so I'm going to show you both just to show you that they come up with essentially the same answer. So in the first one, all we need to know is what the radius is. So if we substitute in 1 for our radius, we would get pi times 1 squared. 1 squared is 1, so we take pi times 1. And pi is 3.14, so 3.14 times 1 would be 3.14 meters squared. All right, if we do it the other way, if we use this formula, the modified polygon formula, we get A is equal to 1/2. The circumference is 6.25, and the radius is 1. So if we multiply all these together, we're basically saying 6.25 times 1 is 6.25. Half of 6.25 is 3.125, which would round to 3.13 meters squared. So you can see that essentially we have the same area here, just a very small difference between the two. So it doesn't really matter which of these 2 formulas you choose to use, they're going to get you basically the same answer. All right, number 3, a square with side of 2 centimeters is inscribed in a circle. So this is highlighted because this is probably a word that we haven't used too frequently. So inscribed just means that the figure is housed completely within the circle, and all of its vertices are on the circle. They touch the edge of the circle. So if I had another this would not be an inscribed figure because not all of the vertices touch the edge of the circle. Okay, so with a square we know that all the sides have the same length. So we know that this is 2 sides, right? 2 centimeters right here. We know that this is 2 centimeters right here. And we know that the radius of the circle goes from the center of the circle to the edge of the circle. So in this figure here, we know that the radius is this segment here. So in order to find that radius, it looks like we have this little right triangle here, so maybe we're going to need to use the Pythagorean theorem again to figure out what our radius is. So if this length of this side here is 2, then that means that this length is going to be half of that because this is the center, so this would be halfway across. So this is going to be 1 centimeter. And same thing with this little piece right here. This is also going to be 1 centimeter. So we now have this little triangle here. So the first thing we're going to do is we're going to find the radius. And then we're going to use that to find the area of the circle. So again, turn your little corner down here into an area. This radius now is going to be our C. So this one is a little bit different than when we were trying to find the apothem. So this is A and B or A and B. It doesn't matter which one you choose. 1 squared plus 1 squared is equal to radius squared. 1 squared is 1. So 1 plus 1 is 2. And our last step, again, is just to take the square root of r. So r is equal to 1.41 or 1.4. So now we know what the radius is. We can use either the pi r squared formula, or we can use the 1/2 circumference times the radius. So if we do a is equal to pi times r squared, that would be 1.4 squared. Sorry, that's terrible. 1.4 squared. So that would be 2 pi, which is approximately 6.28 centimeters squared. If we use this formula, we have 1/2 times the circumference, which we know is this 8.9, times the radius, which is 1.4. So if we take 0.5 times 8.9 times 1.4, times 8.9 times 1.4, we get 6.23 centimeters squared. So again, slight difference. And it's more because the radius is not exactly the apothem. Last one. A wheel of a toy car has an area of 5 centimeters squared and a radius of 1.26 centimeters. 1.26 centimeters. There's a mark on the point of the wheel that touches the floor. So imagine that there's a little dot on that wheel that touches the floor. You start pushing that car forward, so you're back here and you're pushing this car forward, and as you push, the wheel starts to rotate. So as you push it, this mark starts to rotate around, and eventually what happens is that mark touches the floor again. So what is the distance between where the mark started and where the mark ended? Well, this distance would be equal to the circumference of the tire. So 1 revolution of a tire would be the circumference of the tire, whether you're talking about a car tire, a bike tire, a tractor tire, a toy car tire. 1 revolution is equal to 1 circumference. So in order to find the distance, we would just have to do C is equal to 2 pi r, since we know what the radius is. So we would do 2 times pi times 1.26 is equal to